Hello all, today we are going to go with labor variances. Yesterday we have covered with material variances in the previous video. So today I'm going to go with the labor variances and the same similar kind of the sum I'm going to tell you so that it is going to be easy for you to understand. So in this one labor variances, wherein the labor cost variance is the first one, which is nothing but standard hours multiplied with standard rate minus actual hours multiplied with actual rate, or else in simply if I have to say, it is nothing but standard cost minus actual cost. Like yesterday how I have told you, it is going to be the same, that is standard cost minus actual cost. So how I'll get my standard cost is nothing but standard hours multiplied with standard rate, whereas the actual cost I'm going to get when I multiply with actual hours with actual rate. And the second one is labor rate variance. The rate means the price what we pay to a labor per wage rate. So that is going to be in the main standard rate minus actual rate and multiplied with actual working hours. This is something like a material price variance, wherein we used to have a standard price minus actual price, which is multiplied with actual quantity. It is similar to that one. When you just keep your material variances formulas and the labor variances formulas, it's going to be almost similar. The material is being counted in terms of quantity, whereas the labors will be counted in terms of hours. And this one is efficiency. Efficiency is nothing but standard hours minus actual hours, which is multiplied with standard rate. So this is the one which we are going to go with it. Okay, fine. And apart from that, we have two more formulas. So just like how material mix variance we used to have, the same labor mix variance we have got, which is again revised standard hours minus actual hours, which is multiplied with standard. Standard rate is nothing but standard hours of the grade divided by total standard hours into total actual hours. So this is similar to that of yesterday how we have done it. It is going to be the similar one. And labor yield variance is actual yield minus standard yield a multiplied with standard output rate. So this is going to be the similar to that of your material yield variance. And I said, like, whenever you have a loss or a profit, only in such case the yield formula is being used, or else it is not required. And apart from the material, one extra formula what you are going to have is ideal time variance, which is going to be ideal hours into standard rate per hour. Now let's see with the form problem, 23rd problem which I'm taking it, the detail regarding composition and the weekly wage rate of labor force engaged on job schedule to be completed in 30 weeks are as follows, he said. So this is 30 weeks is standard weeks, and the category of the workers he has given skilled, semi-skilled, unskilled. These are the categories, and standard number of workers are 75, 45 and 60, and weekly wage rate per labor is 60, 40, 30. And when it comes to the number of workers in the actual is equal to 70, 30, 80, and actual weekly rate is equal to 70, 50 and 20. The work is actually completed in 32 weeks, it seems. So we have decided for 30 weeks as per standard, but actually it was completed in 32 weeks. So calculate the variance of labor variances he is asking. So shall we begin with the problem solution? Now, I have whatever the question I have shown it. So based upon that, this is a table I have made it. So these from here till here, it is your standard data, and from here it is going to be your actual data. So commonly the particulars column is of three categories of employees we have. One is skilled, semi-skilled and unskilled. Now, he, apart from the rate and apart from the number of workers, he has even said, like, how many weeks the standard weeks are there, and as per actual how many weeks we have worked. So when he has given for the weeks, so number of laborers multiplied with the number of weeks I'm going to find out, and I'll get to know about the total working hours what they have done it. So that's what we are making it. 75 laborers and 30 hours, and whereas 30 weeks, whereas 45 laborers in the semi-skilled, and they worked for 30 weeks, And when it comes to the unskilled, 60 workers and 30 weeks they have worked. So that's how I got my total number of hours they have worked in organization, and this is rate. And when I multiply these two things, I'm going to get the total cost. Like my labor cost variance is going to be easy when I going to make this table. Again, I need not make us separately as a skilled, semi-skilled and all, because I got it immediately here itself. So I need not go for finding out. So that's why I made it easy, my job to be easy. So I have made my cost itself, that is number of hours into rate, we got a cost. Likewise, for actual also we have got 32 weeks. So number of laborers, whatever were there, I have multiplied everything with 32 weeks. So that's how I got these total hours of laborers who are working for 32 weeks in an organization. And the actual rate is 70 as per skilled, semi-skilled 50, unskilled 20. So when I multiplied, I got my actual cost. So simply now my first formula, whatever is my labor cost variance, which is my standard cost minus actual cost. So already I got to know what is my standard cost, that is 2,43,000 minus 2,56,000. When I'm going to do, I'm going to get here how much as that one. I'm going to get somewhere 2,43,000 minus 2,56,000, which is going to get minus 13. So this is nothing but 13,000 adverse. This is how I'm going to do it. Now coming down to the B part, that is labor rate variance. Labor rate variance. And what is that I have told you about? Labor rate variance is, rate is going to be highlighted. So that is standard rate minus actual rate, which is to be multiplied with actual hours, or actual hours, actual time, whatever it has been total they have worked for. So now there is a variation of everything. There is a rate, the rate is different here. So here it is 60, here it is 70, here it is 40, here it is 50. So I need to go with a separate part. So that's why I'm making it here as skilled, semi-skilled, unskilled. So what is the formula? We have got to know, that is actual hours. Everything I have to multiply with actual hours. So this is what I'm going to use it. 2004, 240, 960 and 2560. So here actual hours or actual time, whatever is there. For three of the things I'm going to fill it. That is 2240, 960 and one more is 2560. Now I have to multiply with what? Standard rate. Standard rate for the first one I said what, mark 60, and actual rate is 70. So that is what here we are going to do it. So 60 minus 70. Then second one 40 minus 50, and the last one is 30 minus 20. So here also it is a 10, here also it is a 10, and here also it is a 10. So when I multiply here, I'm going to get 22,400, but it is in a minus, so I'm going to get adverse. And here also it is a 10, so it is going to be 9,600, and it is a minus, so I'm going to call it as adverse. But whereas this one is of a plus 30, so it is going to be 25,600, but it is what? Favorable. So when I go with finding out a net, I am going to go with getting as 6,400, but which is going to be adverse. So this is how I got to know about my labor rate variance. So now in the same pattern, we are going to find it out for our efficiency variance also. So the next one I'm going to go for finding out is my labor efficiency variance, which is standard rate and standard hours minus actual hours, or else I'm going to take it in the place of hours, I'm going to use the time. standard time minus actual time. So as usual, I have to go with again skilled, semi-skilled, unskilled. So standard rate for all the things I'm going to go. So standard rate, I've got 60, 40 and 30. So I'm multiplying as usual 60, 40, 30. Now I have to go for standard 2250 minus 2240. That is what I'm going to do it for all the things. So what is that I'm doing here? 2250 minus 2240. Second one is 1350 minus 960. And the last one is 1800 minus 2560. So that's how when I'm going to get it, I'm going to get first one as it was 250 here, 440 here. So that's the reason it is going to be favorable. Whereas the second one, it is going to be again a favorable itself, because my first number, this is 1350 is greater. But whereas in the last case, I'm going to get adverse. So when I'm making it a net, it is going to be 6600 adverse. So this is how I got my efficiency variance. Now the next one we are going to find out is labor mix variance. Why I have to find out mix variance. Can't I go with this one only? Means when it is necessary is when the quantity or else in the labor variance raise the time or the hours, if they are unequal, then the mix variance has to be must that we have to find out. So here the standard time is 5400, whereas the actual time is 5760. Something I have to equalize. I can't equalize this 5400 to this one, but whereas I can equalize 5760, and standard data also I can convert into the actual data, because this is the one which actually has incurred. So I can't go back here, but I can come here. So that's why my standard data has to be converted here. So the formula for the revised is total actual mix divided by total standard mix into standard time. Individually we are going to take it. So first one I'm going with revised only. So for revised, that too with a skilled one I'm going it. So whereas my total actual mix is equal to 5760, whereas total standard mix is equal to 5400. So one will be the numerator, the other one will be denominator, and individually the skilled and all we are going to find it out. So first I am going with my skilled one. So wherein 5750 divided by 5400 multiplied by, what is the individual one we have to take it? This one. That is 2250, individually 1350, and the last one 1800. So first one is I'm going to go with 2250. And then I have got semi-skilled, same 5760 divided by 5400, but now I said it is what? 1350. And then the last one is unskilled, which is going to be same 5760 divided by 5400 multiplied by 1800. So that is how we are going to find it out. So when I am going to multiply it, I am going to get first one is 2400, second one 1440, and the last one 1920. So how? I'll just show you why. That is 5760 divided by 5400 into first one 2250. So I got how much here? 2399. So which we can convert into 2400. So the second one, if I see 5760 divided by 5400 multiplied by 1350, which I got again 1439 and 99. So that's why I have converted into 1440. So hope so it is clear for you. Now I have got my revised. When I total all these things, it is going to be equal to 5760. Let's try it. The first one is what? 2400. Second one is 1440, and the last one is 1920. 20, which is 5760. So now my standard data also I have converted into the actual data. So now I will simply apply in the formula. So same now, as usual we are going with skilled. So skilled stand, what is the formula I said? Standard rate into revised standard time minus actual time. So standard rate is as usual common, that is 60, 40 and 30. So I'm going with as usual 60 semi skilled is equal to 40, and last unskilled I said 30, no, so unskilled is 30. Now simply revised quantity, first one is how much? Revised standard quantity is 2400 minus actually is as usual, they have not changed, so it will be the same. Then 1440 minus 960 of actual, and 1920 minus 2560. So this will be positive, this is going to be positive, means favorable, and whereas this one is going to be of negative in nature. So when I multiply it, minus and multiply it, I'm going to get 9600. I'll show you. So 2400 minus 2240 multiplied with 60, where I'm at 9600. So this is favorable. And second one is 19,200, it is favorable. And the last one I got, again it is to be the same, that is 19,200, but this is adverse. So when I net find it out here, I'm going, because these two will be one and minus, one plus, one minus, they will be cancelled, and left over will be 9600 favorable. So this is how we are going to do our sum of labor variance.